Induction is actually a three-step procedure which will help us to check the validity of any mathematical result. कोई भी mathematical result अगर हमने given and we need to find out whether it is true mathematically or not, we can make the use of induction. Induction has been derived from the word generalization. So when we, like for example, if a relation is true for n equal to 1, n equal to 2, n equal to 3, n equal to 4, and so on, हमने 4-5 values के लिए check कर दिया. So generally we tend to generalize that. कि वो relation फिर सारी values के लिए true होगा. But that is giving a mathematical treatment to this if mathematical induction. So according to the principle of mathematical induction, if a relation is true for n equal to 1, for n equal to k, and for n equal to k plus 1, अगर इन तीन values के लिए कोई mathematical relation true है, that is we need to check it only for these three values, n equal to 1, n equal to k, and n equal to k plus 1. If it is true for these three values, then it will be true for all the values. अब n equal to 1, n equal to k और n equal to k plus 1 का क्या significance है? n equal to 1 is check. That is, we check whether the relation is true for n equal to 1 or not. n equal to k is assumption step. That is, we assume that it is true for n equal to k. क्योंकि उसी फॉर्म में वो relation given होता है. And then by the help of this assumption, we prove that it is true for n equal to k plus 1. देखो, n equal to k is a general step. तो हमने n equal to k के लिए prove किया, k के लिए assume किया, and by the help of this assumption, we are proving the next step also. So it can be easily assumed. It can be easily, that is, we can conclude. It can easily be concluded that that relation will be true for all values. So basically, the whole idea, whatever I have just said, the whole summary of this is that we just need to check for n equal to 1, assume for n equal to k, and prove for n equal to k plus 1. अगर ये तीनों ट्रू होंगे, then it will be true for all the values. So मैं कुछ क्वेश्चन से आपको ये और अच्छे से क्लियर करा देता हूँ. बहुत सिंपल सा कॉन्सेप्ट है. Best part, not even a single formula in this chapter. Completely, all the questions are based just upon these three things: n equal to 1, n equal to k, and n equal to k plus 1. Nandini, did you try the questions? Bratika, did you try the questions of the first exercise?
Yes, sir.
Yes, sir.
So let me tell you a few questions. अगर किसी में प्रॉब्लम हो पहले आप वो प्रॉब्लम्स पूछ लो इस एक्सरसाइज के. कोई प्रॉब्लम नहीं, सारे क्वेश्चन हो गए. 12th question. Before 12th, any problem? No. Okay. मैं फिर कुछ क्वेश्चंस अपने पास से बता देता हूँ. लाइक फॉर एग्जांपल क्वेश्चन नंबर 5. इसी क्वेश्चन से आपको पूरा कॉन्सेप्ट, दोज आर डूइंग इट फॉर द फर्स्ट टाइम, ट्रस्ट मी, अगर ये क्वेश्चन आपने अच्छे से सुनी, आपको पूरा कॉन्सेप्ट का आइडिया क्लियर हो जाएगा. So this is 1 into 3, 2 into 4, 3 into 5, and so on till n into n plus 2. This dot signifies multiplication. Is equal to n plus 1, 2n plus 7, and whole upon 6. So we need to prove this result by using PMI. So what we do in PMI, we first of all assume let Pn be the given relation or given expression. जो भी expression, जो equation हमें given है, we assume that in the form of Pn. Now, in the first step, we put n equal to 1 in P. Why we write we put n equal to 1? Because we are checking it for n equal to 1. And because we are checking it for n equal to 1, we take LHS, RHS separately. Now, what does LHS means here? LHS means a first term. So 1 into 3, which is just 3. RHS, to get the RHS, in place of n, write 1. So in LHS, n equal to 1 means the first term. In RHS, directly in place of n, write 1. So this will be 1 into 2 into 9 whole upon 6. 2 ones are 2 3s are 3 3s are. So this is also equal to 3. So this implies that LHS is equal to RHS. Therefore, P1 is true. Am I clear with it? We check for n equal to 1. अगर यही पर ही दोनों इक्वल नहीं आते तो फिर आगे क्वेश्चन कुछ नहीं होता. हम यही लिख देते that this relation is not valid. Am I clear with it? So we have checked for n equal to 1, and because it's coming out to be true for n equal to 1, so we'll move on to the second step. So this is what we have checked. Now we'll assume. What will we assume? Let P of K be true. P of K be true का simple सा meaning होता है कि जो हमें expression given है, in that expression, wherever there is n, we will write K. So this will be 1 into 3, 2 into 4, 3 into 5, everything else exactly the same, whatever is given. The only change will be in place of n, this relation will be written in terms of K. So this is equal to K, K plus 1 to K plus 7 whole upon 6. This becomes our first equation. Now, by the help of this, we need to prove the third step. What is the third step? Put n equal to K plus 1. If you're listening to this thing carefully, we have checked for n equal to 1, we have assumed for n equal to K, and now we are proving for n equal to K plus 1. So we'll take LHS. So again, the same thing. That is, in place of n, K plus 1. So everything else the same. The only change will be in place of n, it will be K plus 1. So this will be 1 into 3, 2 into 4, 3 into 5, and so on. The last term will be in place of n, K plus 1. Here also in place of n, K plus 1. So K plus 1 plus 2 will be K plus 3. What will be the preceding term? The preceding term will be K plus 2. Preceding term will be the last term of this, because this is still K and this is K plus 1. So जो इसकी last term है वो इसकी previous term होगी. Why do we need to write the previous term? Why do we require this? बहुत simple सा answer है इसका. We require this so that we can utilize this complete equation 1. So now in place of this complete expression, we can write K plus 1, 2K plus 1 whole upon 7. Because we need to prove the third step by the help of the second step. So in place of this, it will be K plus 1, 2K plus 7 whole upon 6 plus K plus 1, K plus 3. Is it clear? This one? Yeah, sure. This is actually from equation 1 that we are doing, because this completes it. This complete expression is repeated over here. So in place of this, we can write K plus 1, 2K plus 7 whole upon 6, this term as it is. Right? We are utilizing equation 1 to prove the third step. Out of these two, what can we take common? K plus 1. If we take K plus 1 as common, what will be left? K into 2K plus 7 whole upon 6 and plus K plus 3. So this is K plus 1, 2K square plus 7K plus 6K plus 18 whole upon 6. This is K plus 1. This will be 13K. We need 36, splitting the middle term. So directly, just to save one step, I'm writing this as 4K plus 9K plus 18 whole upon 6. K plus 1 into 2K common, this will be K plus 2 plus 9 common, K plus 2 whole upon 6. So K plus 1, K plus 2 and 2K plus 9 whole upon 6. Am I clear with it? LHS completed. Now RHS. What are we doing in the third step? In LHS, we have written K plus 1. So RHS also, in place of n, we'll write K plus 1. So K plus 1. Here also, K plus 1 plus 1. Here, in place of n, K plus 1 plus 7 whole upon 6. So this will also become K plus 1, K plus 2, 2K plus 2 plus 7. So plus 9 whole upon 6. See, both are same. So what do we conclude? LHS is equal to RHS. Therefore, P of K plus 1 is true. We checked for n equal to 1. We assumed for n equal to K. And now we have proved it for n equal to K plus 1. And these are the three sufficient values. So now in the last field, right? Hence, Pn is true for all values of n. n की जगह हम कोई भी वैल्यू पुट अप करेंगे, this relation will come out to be. ये है कंप्लीट प्रोसेस ऑफ मैथमेटिकल इंडक्शन. एक भी क्वेश्चन डेविएट नहीं होगा इन तीन स्टेप से. So in every question we need to check for n equal to 1, assume for n equal to k, and prove for n equal to k plus 1. Clear this thing? जल्दी से नोट करो प्लीज इसको. Let Pn be the given relation. Let Pn be the given relation. First step, put n equals 1 in Pn. So LHS will be just the first term, that is 1. RHS will be 2 into 1 upon 1 plus 1, 2 upon 2 equal to 1. This implies that LHS is equal to RHS. Therefore, P1 is. Am I clear with it? What's the second step? Let P of K be true. P of K be true. So this means 1 plus 1 upon 1 into 2, and so on till 1 upon 1 plus 2, and so on till K is equal to 2K upon K plus 1. Let it be equation 1. What's the third step? Not let, now put. देखो difference है. यहाँ पर हमने check किया तो we are putting. यहाँ पर हमने assume किया so we are using the word let. यहाँ पर again we have to prove, so we are putting. So PLP, we assume, then we again put n equals K plus 1 in P. So taking only LHS is 1, 1 upon 1 plus 2, and so on till, what will be the last term? 1 upon, आप बताओ, 1 plus 2 plus 3, and so on till K plus 1. And what will be the preceding term? Preceding term of this, 1 upon 1 plus 2 plus, and so on till K. Now, in place of this complete expression, we can write, what can we write? 2K upon K plus 1 plus. Now this one, 1 plus 2 plus 3 and so on till K plus 1. ये भी तो sum of n natural numbers हो गया ना? That is till K plus 1. So what will be this result? यहाँ पर n की value क्या होगी? For this expression, what will be the value of n? K plus 1. So it will be K plus 1, K plus 1 plus 1 whole upon. सबसे important step इस question का. देखो 1 plus 2 plus 3 till n. It was n plus 1 upon 2. So 1 plus 2 plus 3 and so on till K plus 1 will be K plus 1, K plus 1 plus 1 whole upon 2. If you understood this, अगर ये नहीं समझ आया तो फिर बेकार, फिर नहीं clear होगा. मैं बता देता हूँ. 1 plus 2 plus 3 and so on Yashaswini till n. It was n plus 1 upon 2, right? यहाँ पर हमारे पास है 1 plus 2 plus 3 and so on till K plus 1. So it will be K plus 1, K plus 1 plus 1 whole upon 2. Right? Now this 2 can be shifted to the numerator. So we'll get 2K upon K plus 1 plus 2 upon K plus 1, K plus 2. What can we take common? 2 upon K plus 1. What will be left? K upon, or only K, plus 1 upon K plus 2. So this is 2 upon K plus 1 into K square plus 2K plus 1 whole upon K plus 2. K square plus 2K plus 1 can be written as K plus 1 of whole square, K plus 1, K plus 2. Now this one and this one cancelled. So we are getting, now I'm rubbing this. We are getting 2 into k plus 1 whole upon k plus 2. LHS completed. Now RHS. RHS in place of n, k plus 1. Whole upon k plus 1 plus 1, k plus 2. What do we conclude? Therefore, P of k plus 1 is true. And hence, Pn is true for all values of n belonging to. थोड़ा सा तो क्लियर हो गया होगा आफ्टर द सेकंड क्वेश्चन. So every single question of induction, n equal to 1, n equal to k, n equal to k plus 2. ये expression हमें given था 2 raised to the power 3n minus 1. We were required to show that it is divisible by 7. So what we have done, जो तीन steps होते हैं induction के, वही basic तीन steps. Put n equal to 1. That is, we are checking for n equal to 1. तो हमने n की जगह 1 put up किया. So 2 raised to the power 3, 8 minus 1, which is coming out to be 7, which is divisible by 7. So P1 condition हमारी true हो गई. Now we are assuming P of k to be true. So 2 raised to the power 3k minus 1 is divisible by 7. Because this is divisible by 7, so this can be written as product of 7 and some integer. So m we have taken as an integer. So यहाँ से हमने 2 raised to the power 3k की value find करी. Then after that, in place of n we are writing k plus 1. So उस expression को में हमने n की जगह replace कर दिया k plus 1. So 2 raised to the power 3k plus 3. Parts अगर add होंगी तो numbers multiply होंगे. In place of this, we are utilizing equation 1, 7m plus 1 into 8 minus 1. We are able to get 7 as common. Because we are able to get 7 as common, so this means that this is divisible by 7. So that means जिससे भी divisible show करना हो या जिसका multiple show करना हो, वो common आना चाहिए. Because we are able to take 7 as common, so therefore we can say that this is divisible by 7. So condition fulfill हो गई. That means pk plus 1 true है. And if it is true for n equal to 1, n equal to k, n equal to k plus 1, then it will be true for all values of k. आपको समझ आ गया? अभी almost या complete? Complete. Complete. Sure.